lithium is the red color flame. Lithium is the red color flame. Sodium is yellow. Potassium is violet flame. Is reddish violet flame, and cesium is the blue flame.
Okay. Why the beryllium and magnesium do
Now
not give
cesium,
the okay, no problem. Beryllium and magnesium do not give flame test. Why?
sir, because their electrons are not transferred to the excited state, so sir, they do not have any spectrum, and so they do not give any flame color.
Okay, because their ionization energy are very high. That is why. Okay.
Yes.
Now we are going to study the
Talking
group.
about cesium is due to cesium is used due to it is having the lowest ionization energy. Density of alkali metals generally low, and sir, as down the group the density increases. Sir, lithium, and sir, we are talking about monoxide and peroxide. Monoxide, the oxidation number of oxygen is -2. In peroxide, the oxidation number of oxygen is -1. Talking about superoxide, the number of oxidation number is -half. So now oxidation number of oxygen is -half. So, now if we talk about stability and basic strength, if we go down group with so their size in their bond strength decreases. So sir, they give easily, they start giving easily the OH ions, so their basic strength increases.
Okay. What about the if anomalous properties? What do you mean by anomalous properties? Which element shows the anomalous properties?
So anomalous properties are the properties which are different from the rest of the group. So generally, the first element of all the groups show the anomalous. Generally, the first element of all the groups show the anomalous properties.
What is the causes of anomalous properties? Causes of anomalous properties. What the reason behind the anomalous properties?
The causes of anomalous properties is
if something is something is showing anomalous properties, then rest of the element, there must be some reason behind this.
yes.
What is? Okay, no problem. Causes of anomalous properties. First one is small size in the group. Is small size in the group. They are having the first member as they are first member as they are first member. So if they are the first member, so their size will be what? Their size going to be small only. Second one, if their size are small, so ionization will be high or low?
Yes.
High ionization energy. High ionization energy because size are small. So ionization energy will be what? That is going to be also small. This is second point. Third one, if you are going electronegativity, you tell me, if you are moving down the group, electronegativity, what will be there? Electronegativity will be high because it will be high in group. Why? Because it is the first member and down the group electronegativity decreases. Third one, okay, lack of d orbital. Lack of d orbital. They do not have d orbital. Getting my point? Why? If you see, this belong to group number 2, period number 2. If they are belonging to period number 2, means this will be the what? 2s and 2p will come now. 2s and 2p. And first period, that is 1s. So d orbital involved from the what? There is third orbit. 3s, 3p, 3d.
Yes.
These are the for the for third period. So they belong to, if you talk about lithium or the beryllium, lithium and beryllium, they are the what? Which one? Period 2. So period 2 is having no d orbital. Period 2, if you are talking always means no d orbital. So no d orbital, so their bonding will also be like that. They cannot extend their octet. Okay. So lack of d orbital, neither they can gain the electron nor they can expand the octet. Like one question we studied earlier, what the question there? That is H2S. Okay. H2O is there. H2O. Oxygen is forming the two bond. Okay. But here is, if you talk about sulfur, it is forming the how many bond? SF6. Here you take the other example in spite of taking H2O. You take SF2 is maximum. OF2 is maximum. This is maximum. But here sulfur is forming the 6 bond. Although it is belonging to what? Although it is belonging to group number, which group? Tell me group number of oxygen and sulfur.
Sir, I'm not getting this one. Can you explain from the beginning once again?
How many bond are there? Oxygen is having how many bond? One fluorine, one fluorine. Sulfur is how many bond are there?
6.
6. What is the reason? They belong to group number. Can you tell me the group number?
So
Sulfur and
sulfur
oxygen.
belongs to
Oxygen, sulfur, selenium, tellurium, polonium. What group?
sir, this is 13, 14, 15. 15.
No. How can you say? Group 16. 6 valence electron. Na? You can check directly. Oxygen is how much? 8. So 2 comma how much will be there? 2 comma 6. 6 valence electron means 6.
Oh.
Group number 16.
Okay.
If I will ask you this one, F, Cl, Br, I, which group they belong to? Group.
This is 17.
Group 17. Why group number 17? Group 17 because if see this one, all the elements, that is 2 comma 7. 7 valence electron, that is going to be last digit 7. Okay. If I will ask this element, which group? If I will ask you.
So this is the 15.
15 group. Group number 15. Don't get confused. Okay, group 15.
No,
Okay.
nitrogen is 7. No, 7 is 2, 5. So it should
Very
be
good, very good. Tell me this one, which group?
13.
13, very good. This one.
So this is 14.
14 group. Okay, good. So the question is what this belongs to group number 16. So here oxygen maximum bond is 2. Maximum is 2. And here is sulfur. Sulfur maximum 6. What is the reason?
Understood.
Reason. Why sulfur is 6 and oxygen is 2? Even though they belongs to which group? Belongs to group number, which group? 16 group. So they should have the same bond now. Why the bond are different? OF6 is not possible. But SF6 is possible. Reason. SF4 is possible.
And SF2 is
Have you studied the extended octet? Have you studied the extended octet? Expanded octet?
Yes, sir.
What is there? That is in case of sulfur, they are having vacant d orbital. Sulfur
Yes, sir.
contain what d orbital? So if there is d orbital,
Yes.
it can extend d orbital, it can extend valency, it can extend valency. Yes or no?
Yes, sir.
Okay. So that is why. If I will see, this is NCl. NCl5 not possible. Not possible. NCl5 not possible, but PCl5 possible. What is the reason? Reason.
Sir, same activity also having the
What
backing d
same?
orbital.
What same? That you explain. What the reason? Nitrogen, you see, that is, if I will do the nitrogen, nitrogen. So nitrogen 7, 1s2, 2s2, 2p3. D orbital will not come. But if you go phosphorus 15, 1s2, 2s2, 2p6. 3s2 3p, what is there? 3p3 3d0. So it is having vacant orbital, yes or no? D orbital is vacant. So it can form the extend the octet. How can it extend the octet? Here is the paired electron are there. That paired electron will go where? It can go to the, this electron will go here. So total unpaired electron will be 5. So n is equal to 5. It can form the bond, 5 bond. But in case of nitrogen, it cannot go because there is no vacant d orbital. There is no 2d. 2d is
Sir,
not
repeat
possible.
1 second. Sir, please repeat this one also. Sir, from the beginning.
Here see, if you see this one, in case of nitrogen, here is the quantum number for valence shell is how much is there? That is 2. And d orbital start from third orbit, 3. So it is not having the 3, na? This is only 2 orbits are there, 2. K and
Yes,
L. K and L. So K and L are there. So it cannot extend. This cannot be going to jump. Where it will go jump if there is no d orbital. Now in this case here 3s2 3p3 3d0. Now when it is forming the bond, this electron s electron can jump here, na? So next case what you will find? That here you will find that is number of unpaired electron will be more. How many will be there? Now in the excited state, it will be that is 3s1, 3s1, 3p3, and 3d1. So this is C, one electron. Here is the 1, 1, 1. And lastly, this is also going to be 1. So total number of valence electron is going to be 5. N is equal to 5 means 5 bond. Can't you understand?
yes, sir.
Okay. This was the point. Don't forget this thing. These are the important basic concept. Okay. Group 13 we are going to start. What is the group 13 element? Outermost. See, the last electron enters into which orbital? P orbital. So if the last electron entering into P orbital, that is going to be what type of the element? That is P block element. Okay. P when you talk about p orbital is 3, you know, as we know that the number of p orbital is 3, and therefore the maximum number of electron that can be accommodated in a set of p orbital is 6, because one orbital can have how many electron? One orbital, if I will write one orbital, so one orbital is equal to 2 electron. So 3 orbital is equal to how many electron? 3 orbital is equal to 6 electron. So because of this, consequently, there are the 6 groups in P block, 6 group of the P block element in the periodic table, ranging from 13 to 18. 13 to 18, extreme right side of the periodic table is called the P
That
block.
means all are the people. That side,
All
all
are,
are people.
yes,
Right side.
right side. What are these elements are there? Like the boron, carbon, nitrogen, oxygen, fluorine, helium, head of the group. Okay, so that is why called boron family, carbon family, nitrogen family. These are the called, right? Now next one, see. Their valence shell electronic configuration can be NH2. N will be fully filled. है ना? N will be fully filled because group 1, group 2. And ND, it will be 1, 2, 6. Group 13, ND1, ND2, ND3. This one. Except for helium, the inner core of the electronic configuration may, however, differ. Inner core of electronic configuration. What do you mean by inner core of electronic configuration? Wait, here you will be. The difference in inner core electronic electron element greatly influence their physical properties, such as atomic and ionic radii. You can close your that is what is called too much sound is coming. You can close the that one sound one.
Okay. Okay.
When I will ask, then you can open. Na?
Just 1 minute.
Hmm.
Yes, sir. Sir, continue. We can continue, sir.
Okay. Ionic radii. Yeah, ionization enthalpy. As well as chemical properties. What is there? Inner core electron is there, na? Inner core. These are the inner core. Inner core I will explain you. This inner core is going to no, differentiate what the ionic atomic ionic radii, ionization energy, as well as chemical properties. First of all, you should know what is the inner core. See, if you go now, wait. Let me take the page. Here we are having the boron, aluminum, gallium, indium, thallium. Okay. So here you see this the configuration is 1s2, 2s, 2p1. Right. Here is 1s2, 2s2, 2p6, 3s2, 3p1. Here if you go this one, so 4s2, 4p1. So here you see next one, this one. So here will be, this is the 5s2, 5p1. This is going to be 6s2, 6p1. So these electron are there, like 1s2 here also will be there, 1s2, 1s2 everywhere will be there. So these are called, what is called? This is called inner core. Inner core electron. Inner core electron. Do not participate. This is also whatever the, except this one. You see, which one is we are excluding? Whatever the inner are there. 2p you leave. 2p. This one we cannot 6. P orbital. They are the p block. Other are the called the inner core electron. Most inner core electrons are this. Okay. So let us see the other one, what the properties they are saying. Line by line, you kindly read the NCRT. Consequently, a lot of variation in
I am
properties of
reading with you only, sir. As you are doing, I am also doing.
not getting.
Sir, I am saying that as you are doing that one, sir, I am also reading with you only, sir. I am
Oh, okay,
continuing.
good. Consequently, a lot of variation in properties of element in group of p block observed. The maximum oxidation state shown by p block element equal to the total number of valence electron, that is sum of the s and p electron. So that is what the main oxidation number is +3. Why? Because general configuration is ns2 np1. So 2 electron is this is. So the oxidation number is 3. But you see, this is not the only one oxidation state. See, the number possible the number of possible oxidation state increases towards the right of the periodic table in addition to this so-called group oxidation state. So if the number of oxidation is number of electron is equal to number of valence electron, number of v electron is equal to group oxidation number, group oxidation like sulfur is group oxidation number can be 6. Okay, because 6 valence electron. If we talk about halogen X, group oxidation number is 7 because valence electron is 7. If you are going, that is boron family, +3 because valence electron is 3. If you are talking about carbon, +4 because valence electron is 4. Now, p block elements may show their oxidation state, which normally but necessarily differ from the total number of valence electron by unit of the 2. So when you are reaching off, see, one group to other group, if you are going, so here you see the line is very important, this line. Na? Here, p block elements may show other oxidation state, which but not necessarily differ from total valence electron, but unit by 2. What unit by 2? See the very important point. See, which one I am telling this one? Suppose boron, I am going boron, okay. Then I am going aluminum. So either you see if the first oxidation state is +1, then it is the +3. So what is the difference between these two oxidation state? +2. Suppose oxygen you are you go for the group 16. Group 16. If that is the +4 is there, +4. The next one will be how much? +6. What is the 10?
Plus,
+2. So if suppose you are going the chlorine, so chlorine suppose +5 is there. Okay, the next will be +7. So change will be always +2. Okay, that is what the point is saying. You read once more. if you can, P block elements may show other oxidation state. How much other oxidation state? Which normally, but not necessarily, differ from the total number of valence electron by 2 units. Two oxidation state are differ by what? Two. Getting? The important oxidation state exhibited by P block element are shown in table 11.1. In boron, carbon and nitrogen family, the group oxidation state is the most stable state for the lighter element. What is lighter element? Group oxidation state is stable for which element? Lighter element, first two element. Lighter element. Can you understand this? In the group. However, the oxidation state 2 unit less than the group oxidation state become progressively more stable in heavier element. So in heavier element, how many oxidation state will be there? 2 unit less. 2 unit less means that is going to be +1. In case of group 13, the occurrence of oxidation state 2 unit less than the group oxidation state is attributed by inert pair effect. Very, very important. Inert pair effect. Now see, here you see this configuration. You see the configuration. What the configuration you will find? This electron is there. 2s2, 3s2, 4s2, 5s2, 6s2. In heavier element, here I am writing, in heavier element, elements do not participate in oxidation state. Participate in oxidation state. Where? Do not participate in oxidation states. So do not participate in oxidation state. So what will be there? So if they are not participating in oxidation state, so in heavier element, oxidation state is how much? +1. Oxidation state is +1. Called, what is called? Inert pair effect. Inert pair effect. Pair effect. Inert means not reactive. Paired means these two electron not participating. So that is what the oxidation, only one electron left. So that is +1 oxidation state. Getting? So, getting this one inert pair effect or not?
Yes, I getting.
Okay, thank you very much. Now see the configuration. Here you see the group 13 element configuration NS2 NP1, group 14 NS2 NP2, group 15, group 16, group 17, group 18. Now you see the group oxidation state. Group oxidation state. First member of the group are what there? Anomalous properties. They will show anomalous properties. Boron, carbon, nitrogen, oxygen, fluorine, neon. Group oxidation state. Group oxidation state equal to number of valence electron. So 2, 1, 3. 3 valence electron, 4 valence. Last digit is called what is? That is called the valence electron. As many last digit are there, that is explaining the valence electron wherever. So 3, 4, 5, 6, 7. So valence, group oxidation number 3, 4, 5, 6, 7, 8. Now, next one you see. Other oxidation state. So differ by 2, less than 2. In heavier oxidation, heavier element, the oxidation state will be less by 2 units. So here +3 is there, so that is less than 2 unit. So it will be +1. What will be there? +4 is there, so +2, +3. 6 is there, +4. 7 is there, +5. 8 is there, +6. Other than this also there. These are also there. That is not by +2 unit. If you see this one, how much difference? +2. This one different, +2. Okay. This is
Yeah,
exception.
so this one's different. This one's difference is -6.
This is somewhere there is exception. Where the -6? Acha, this one. Only the first oxidation state is considered for this one, like major one. This one, first oxidation state, because two are stable, either higher or the lower. Either higher or lower. Here you will find +2. Can you check? No.
Sir, here is -2.
Everywhere you will find -2. Only the you take the measure lowest and highest oxidation state. The difference will be -2. This difference -2 is called what? Inert pair effect.
Inert pair effect. Okay. Understood.
Now, next one. Can you please erase what you wrote on the screen?
Yes.
Hmm.
So I can.
Thank you very much. Now, next one. The relative ability of these oxidation state, these oxidation state, group oxidation state, and 2 unit less than the group oxidation state may vary from the group to group and will be discussed at the appropriate places. So when you study group element, there it will be there. It is the general one. Next one, see. It is interesting to note that the non-metal are metallites, non-metal and metallites only in the P block of the periodic table. What are there only? Non-metals are there. And then what is there? Metallites are there in P block. The non-metallic character of the element decreases down the group. Non-metallic character decreases down the group. In fact, the heaviest element in each P block element is most metallic in nature. This change from non-metallic to metallic character bring diversity in the chemistry of these elements depending on the group to which they belongs. So what they are saying? So in the top it is their non-metal. In the top it is their non-metal. And in the bottom metallic character will be high. In the bottom metallic character will be high. Getting metallic character high. So this is next one you see. In general, non-metals have, here you see, higher ionization enthalpy and higher electronegativity than the metals. In general, non-metals have higher ionization energy because they are present what? Left side. Hence, in the contrast to metal, readily form the cation, and non-metal readily form the anion because the non-metal gain the electron and metal lose the electron. The compound formed by highly reactive non-metal with highly reactive metal are generally ionic. What type of compound they are forming? Ionic compound are forming because of the large difference in their electronegativity. Since their electronegativity value are the large difference in the electronegativity value, they form the compound. What are they? Ionic. On the other hand, compounds formed between the two non-metal themselves are largely covalent. So two non-metal like that N2 is there, O2 is there, they are the Cl2 is there, they are the covalent. But other, if you're talking about NaCl, metal, non-metal, that is large difference in electronegativity. So ionic. In character, because of a small difference in their electronegativity. So a small difference is there, that is going to form the covalent character, covalent bond. The change of non-metallic to metallic character can be best illustrated by the nature of oxide they form. So non-metal form acidic oxide and metal form the basic oxide. The non-metal oxides are acidic or neutral, whereas metal oxides are basic. Now see, this is NCERT book only. The first member of the P block differ from the remaining member of the element corresponding a group in two major respects. The first is size of the all the other size. First the size and all other properties which depend on size. Thus, the lightest P block element show the same kind of differences as the lightest S block element. So like the lithium shows, beryllium show the anomalous properties now. Similarly, these elements also first member show the anomalous properties. Like the second important difference which applied only to the P block elements arises from the effect of d orbital in the covalent in the valence shell. Heavier element is starting from the third period onward. So heavier element third period they are starting and they are having what? That is the d orbital. Like if you see boron, aluminum, gallium. So boron you see, boron is 5 and 13. So 1s2 and 2s1, 2s2, 2p1. This is there. So there is no 2d, but here you see 1s2, 2s2, 2p6, 3s2, 3p1, 3d, 0. So d orbital is there, na?
Yes.
So that is what is starting from the third period onward, and there lack in the second period element. So d orbital is lacking in the second period, but third period onward it is there. The second period element of p group is starting from the boron, restricted to maximum covalence of the 4. How much maximum covalence can be? 4, using the 2s and 2p orbitals. In contrast, the third period element, p block with the electronic configuration 3s2, 3p1, have the vacant 3d orbital, getting vacant 3d orbital, lying between the 3p and 4s level of the energy. Using this d orbital third period, element can expand their covalence. What they are saying? They are expanding their covalence. 4. For example, while boron forms only Bf4 minus, aluminum gives AlF6. How many? 6 bond it is forming. The presence of these d orbital influence the chemistry of the heavier element in number of other ways. The combined effect of the size availability of d orbital considerably influence the ability of these elements to form the pi bond. So they are also forming because of the d orbital, d pi bond they form. Okay, because what is happening? This type of the overlapping is there na, this type. So this is one element, and another element also can form the pi bond like that. Side by side overlapping. This is they are going to form the pi bond. So the next point, see, the first member of the group differ from the heavier element in the ability to form p pi multiple bond. The first member of the group differ. What they are saying? The first member, first member is forming p pi bond. Other member can form the d pi. Firstly, here you see, it's because of a small size, little bit here. Wait. This line you clear here. The first member of the group differ from heavier element in its ability to form p pi multiple bond. Like carbon double and triple bond, they are forming first member because it's small size. Nitrogen form triple bond. Other second member like CO, CN, they are forming the pi bonding. Is not particularly strong for heavier element. In heavier element, it is not strong. P block element. The heavier elements so form pi bond, but this involves the d orbital. What is d pi? Yeah, d pi p pi. D pi either they form or the d pi p pi. As the d orbitals are higher energy than the p orbital, they contribute less to the overall ability to molecule than the does p pi bonding of the second row element. However, the coordination number in species of heavier element may be higher than for the first element in the same oxidation state. See, the coordination number in the species of heavier element may be higher than the first member. So in the higher element, coordination number will be high. For example, the +5 oxidation state, both nitrogen and phosphorus oxoanion NO3 minus 3 coordination with pi bond involving one nitrogen p orbital, while PO431 4 coordination involving s, p, and d orbital, contributing to the pi bond. In this unit, we will study themselves. We will study the chemistry of group 13 and 14 elements for the periodic table. So we are going to study the 13 and 14. So group 13. You said you want to go for 10 minutes, na? 15 minutes.
No, sir, that okay, sir.
Okay.
Sir, I will have my breakfast.
Okay. After breakfast, you call me.
Sir, sir, you please be on this link only, sir. Once I eat my breakfast, I'll just unmute
No.
my mic and.
Okay. Here is in 1 minute. It is
Okay,
disconnecting. I joined
okay, sir.
today
Then
with
I will.
the mobile data because the Wi-Fi is not working today here township. So 15 minutes you call me after 15 minutes.